Hey guys, Mr. Marone here. Welcome back. So today we're going to wrap up our last, we're going to start our last unit of information for the proof unit here, G.SRT.B.5. And what we're going to focus on today is kind of building on what we did when we proved the Pythagorean theorem, where we used triangle similarity specifically with right triangles here. And we're going to look at something called the geometric mean. So the geometric mean is a proportion. And in that, it's a proportion where the same value is in the numerator in one of our fractions, or one of our ratios, and the denominator of the other ratio. Okay, so it's the numerator of one value and the denominator of the other ratio. So here we've got an example would be, x over a equals b over x, where x has one numerator, one denominator, and it's going to end up giving us x squared equals a times b when we were to solve out our proportion using cross products property. So, for example, the two numbers of a geometric mean are the a and the b. The x's will always stay as an x. So for instance, if we're looking at the geometric mean of 2 and 8, we could have x over 2 equals 8 over x. When we cross multiply, we have x squared equals 16. Take my square root, and I have x equals plus or minus 4 as my geometric mean. And we use GM, my initials coincidentally, to indicate geometric mean. I'm going to now pause the video and let you guys try finding the geometric mean of 6 and 24, and we will come back with answers in a moment. All right, welcome back. So as you can see in the second one, we ended up with another perfect square, square root of 144, which gave us plus or minus 12. We do get two answers when we do these. And so my geometric mean of the second one was plus or minus 12. In our third one, we ended up with x squared equals 75. When I take the square root of 75, it is not a perfect square. But what I can do is break it apart into the square root of 25 and the square root of 3. The square root of 25 is a perfect square, so that allows me to get a 5 as a value, and then the square root of 3 we can't simplify anymore. So my answer would be plus or minus 5 square root 3. We deal a lot with geometric mean when we have right triangles, and specifically when an altitude is dropped down, like you see here from 1 to 2. BD is an altitude of triangle ABC. Okay? And what that does is it creates three right triangles. The altitude comes from a vertex down straight to the opposite side and creates right angles, as you can see at point D. And it really creates three similar right triangles. And it creates all these different relationships. So we've got what we refer to as our left triangle, our right triangle, and then our whole triangle. Okay, left, right, and whole triangle. And the first one we're going to look at are the left triangle and our whole triangle. Okay? As we saw when we proved the Pythagorean theorem, our left triangle is similar to our whole triangle by angle similarity. Okay? If we notice in our picture, they both share the congruent angles here, our circle, our x, and our right angle. So we have enough to say that they are similar by angle. So that allows us to say the following proportion. That allows us to say the left triangle over triangle W gives me AB, side AB, which is our hypotenuse, over AC, which is my hypotenuse. And that is equal to AD, which is my short leg, over my short leg, which is AB. And if you notice, you've got your geometric mean here. Okay, so we had hypotenuse over hypotenuse equals leg over leg, and it's the short leg on each of these, SL. Okay, and when we work this out, we have AB squared equals AD times AC, and if we took our square root, AB's value equals the square root of AD times AC. So this is a shortcut for us when we get to actually solving these geometric mean problems. Let's take a look at the second one. So our second one involves our right triangle, the right-hand side triangle, as well as our whole triangle. Okay? And in this case, our right triangle is similar to our whole triangle by angle-angle similarity, just like we saw with our proof before. And with that similarity, it gives us the ability to set up another proportion. So we're going to have our triangle on the right over our triangle, that's the whole triangle here. And once again, we're going to do our hypotenuse over hypotenuse to start. So replacing hypotenuse with our right-hand triangle, we've got BC as the hypotenuse, and that's going to be over AC, the hypotenuse of the other one. And then we're going to use the long leg, which in this case of our right triangle is DC, over our whole triangle is BC. And once again, we end up with a geometric mean here. So BC squared is going to be equal to AC times DC, not the band. And when we take our square root, we have BC equals the square root AC times DC. Okay? And what makes this so great is we're going to use shortcuts here, just like the last one, when we're going to be solving these problems. And you'll see how that works when we get into an example of this. So our third one, our third and final geometric mean setup here, is when we compare our left triangle and our right triangle, the two smaller ones that are inside contained in the bigger one. Okay, so we can say once again that the left triangle is similar to the right triangle by angle-angle similarity. And that allows us to set up the following ratio, our left triangle over our right triangle. And we're going to use the smaller side, so our short leg over our short leg, with our left triangle, that would be AD, and with our right triangle, that would be BD. And then we are going to use our long leg over long leg, which replacing this is BD over my long leg in this figure, which is DC. And once again, we have our geometric mean. BD squared equals AD times DC. So taking our square root, BD equals square root of AD times DC. Now let's take a look at how this applies. So you've got 4 geometric means here that we're going to try to solve. Okay, they run down a line in your paper, and on here they're all kind of stacked up, so I'm going to stack up my answers as we work down it. And if you notice in the first one, we have that same setup that we did for our example here. So what I'm first going to do is, if I look at my x over here, x is my hypotenuse of the small one, and it's my small leg of the large one. So we can look back to our geometric mean 1. We're using the left triangle and the large triangle. And in that case, we did hypotenuse over hypotenuse and short leg over short leg. So I've got hypotenuse x over hypotenuse, this whole thing, 13, equals short leg 4 over short leg x as my setup there. And when we cross multiply, we get x squared equals 52. Take my square root of both, and simplifying out, I get x equals 2 square root 13. Since these are distances, we do not need the negative value. Now, if we were to move this one out of the way here, move these down, and we'll deal with them in a second here. If I wanted to deal with y, so this was to solve for x, I wanted to solve for y. Y happens to be the long leg of my left one. It happens to be the short leg of my right hand one, and it doesn't have any relationship in regards to our figure in our larger figure. Right? So we're going to have to utilize something a little different here. So if we look through our options here, now if we want to solve for y, we look at where y is. Y happens to be the long leg of my left-hand figure and the short leg of my right-hand figure. So those are the two that I'm going to have to use. That's where the shared side is. And so we said it was short leg over short leg equals long leg over long leg when we looked at our third geometric mean here, because our side that we're looking for with y is BD. So if we plug in here, we've got short leg of 4 over short leg y equals long leg y over long leg 9. And we end up with y squared equals 36. So taking square root, y is going to give me 6 centimeters for that value. So I've got 6 here, and I've got 2 radical 13 here. So to finish this off and to solve for z, z is the hypotenuse of my right-hand triangle and the long leg of my whole triangle. So I'm going to use those two sides. We have no relation with z in our small triangle. And if we look back at our second geometric mean, we used my BC, which was hypotenuse over hypotenuse, and then we had DC, which was long leg over long leg. So we're going to do the same thing here. We're going to do hypotenuse over hypotenuse equals long leg over long leg. And plugging in, I've got my hypotenuse of z over my hypotenuse of 13 equals my long leg of 9 over my long leg of z. So I have z squared equals 117. And when we simplify that out, we end up with 3 square root 13 centimeters. Okay. So if we were to just go back, now looking at an example of this, and fill in some notes for these, we've got our hypotenuse and short leg relationship for mean 1. For mean 2, it's going to be hypotenuse over hypotenuse equals long leg over long leg. And remember, it is triangle on the right over the whole triangle. And in mean 3, it is going to be short leg over short leg equals long leg over long leg. And once again, this is left triangle over right triangle here. So with that being said, I want you to try 2, 3, and 4, which I've moved around. You have them on your paper. And when you come back, I will have answers posted for each one of these for you. All right, welcome back. So if we look at our second example here, if we think back to the first one, we had 3 things that we were looking for. We had x, we had y, and we had z. So we had this shortest side of our outside triangle, we had our altitude, and we had our longer side of our outside triangle, or our whole triangle. So if we keep that in mind and we kind of work our way across that same way, we end up with starting with 6. So it would be the hypotenuse of my small triangle over the hypotenuse of my larger triangle, 6 over 10, equals the short side over the short side, so x over 6. You end up getting 3.6, which we're going to utilize to solve for z and for y. So if we utilize that, 3.6 is x. This littler piece inside of my right-hand triangle is 6.4. So next, let's try to find z, this outside one. That is the hypotenuse of my right triangle. So hypotenuse over my, my longer leg of my outside triangle over my longer leg of my inside triangle, z over 6.4, equals my hypotenuse of 10 over my hypotenuse of z. And when you solve out, you end up with 8 centimeters there. And our last one is we have to find the altitude itself using the small one on the left and the medium-sized one on the right. So I've got my short side of 3.6 over my short side of y, and then I've got my long leg of y over my long leg of 6.4. And when you simplify all of this out, you end up with 4.8 centimeters there as a rounded answer, since we had decimals prior. In the third one, we're once again looking for the same 3 things. If we notice, we can't find y because we have to find x, and we'd have 2 variables in there. So we're going to start with our inside one here and say that it's our smaller side over our smaller side, x over 5, and then I've got my long side 5 over my long side 12, and we end up finding that x is 2.08. Once we have that, we can find y. We would take our hypotenuse over hypotenuse, which was 12 plus 2.08 for 14.08, and then I did my short leg 2.08 over my short leg y, and I ended up at 5.41 as a rounding. To find z, I would use my hypotenuse of my right triangle over my hypotenuse of my whole triangle, so z over 14.08, And then I would use my long leg 12 over my long leg z and solve out and get approximately 13 there as my final answer. In our fourth one, the picture's moved, but it's still the same process. We're still looking for y, for z, and we're going to use this side 9 on that outside part. So I'm going to start there and go my hypotenuse of 9 over my hypotenuse x plus 3, this whole quantity, segment addition. And then I've got my short leg 3 over my short leg 9. Cross multiply, and you end up with x equals 24 centimeters. So that means this whole hypotenuse is 27 centimeters. Next, we'll find our altitude, z. And I have my short side 3 over my short side z, and then my long side z over my long side 24. When you cross multiply and solve, you end up with z being 6 square root of 2 centimeters. And finally, to find y, that's my hypotenuse of my my right-hand triangle. So it would be hypotenuse of y over hypotenuse of the whole thing, 27. And then it's long leg 24 over long leg y. Cross multiply and solve, and you get 18 square root of 2 centimeters. So these are tricky. I don't want you to get frustrated or turned around. Please watch this video again if you get stuck, and be sure to ask questions when you come into class, or send me an email with questions, or shoot them to me on Google Classroom. However you want to approach getting questions answered, make sure you're getting your questions asked and getting answers for this content. It is heavy on algebra, and it's heavy on knowing your number sense, so we've got to be careful with that. So try tonight's homework and bring in any questions you have tomorrow.